Okay, let's pick up with Chapter 13, Part 2. We're on the slide distribution of glaciers. Keep in mind there's two factors that are going to affect the distribution, and that's going to be the need for adequate snowfall and also the need for cold enough temperatures. You do see valley glaciers on the highest mountains in the western U.S. as well as Canada and some northern countries. Now, glaciers also have a budget, and that budget is between a balance between the expansion and contraction in response to accumulation and wastage. If we look at the figure at the bottom of the slide, we can see the zone of accumulation. That is going to be the area where you have more snowfall than melting, and then the zone of wastage where you have more melting than accumulation. These two zones are separated from one another by what's known as the Föhn limit. So if my Föhn limit moves up the glacier, it indicates a negative budget and the glacier is receding. If my Föhn limit moves down the glacier, it indicates a positive budget and my glacier is advancing. This line right here shows what's known as the terminus. If the glacier has a balanced budget, then the terminus is going to remain in the same position. In terms of movement rates for your glacier, valley glaciers typically move faster than continental glaciers. They move more rapidly on steeper slopes, and they typically move faster in warmer months because that melting is going to increase the basal slip. Now, if you look at the bottom on the lower left, you see a series of arrows and arrowheads. The length of these arrows lets you know where the fastest rate of movement is going to occur. So in the top picture, you see the fastest rate of movement is near the center. In the bottom circle I've drawn, the fastest rate of movement is near the top. This picture on the lower right shows glacial surge. That is a short-lived episode of accelerated flow. During this time, the glacier's surface breaks into a maze of crevasses, and its terminus, which in this one, the terminus is right here, is going to advance. Glaciers are very effective at erosion and transportation because they can carry anything that's in their path. They're very effective at moving unconsolidated material. A glacier does something that's known as plucking or quarrying, in which the ice freezes in the cracks and crevices of your bedrock, and eventually it's going to pull it loose. You can see down here on the diagram some evidence of plucking. Now, bedrock is going to be eroded through abrasion. The picture on the right shows what's known as glacial polish. When your surface actually gets polished because of the glacier moving over it, and you can see how it starts to glisten in reflected light. We also see in this picture on the left a series of fine lines that you can see in this rock. Those are known as glacial striations. They're a series of parallel lines. It almost looks like you took a knife and you carved them in. That results when the glacier moves over a surface, and the particles that are suspended in the glacier on the bottom are actually going to form scratches in the rock. The picture on the right, you can see how the water is kind of milky looking, and that is because of the amount of rock flour that's suspended in that water. So what's going to happen, abrasion actually is going to pulverize the rock, and it's going to yield that finer material, that silt and that clay-sized particles, which have that consistency of cake flour, and it gets transported in that water. Now, in regard to sediment, most of the sediment we see in continental glaciers come from abrasion of your bedrock. Most of our sediment we see in valley glaciers come from the abrasion and the plucking, as well as the mass wasting. This picture on the right shows you some debris from a glacier in Alaska. Now, glaciers have erosional features, and there's certain features that are related to valley glaciers and continental. Let's go through this list on those that are related to valley glaciers. The first one is a U-shaped trough. So you can see in this top picture, you see the nice V-shaped profile. That is characteristic of all our river streams. Downcutting are going to make that nice V-shaped profile. Well, when a glacier moves through an area, it's going to erode the area, and you're going to wind up with a nice U-shaped profile. So that's one way to tell if a glacier's come through an area. You might also see what's known as a fjord, which is shown in the picture on the left. So a fjord is just an arm of a sea that extends into that glacial trough that's eroded below sea level. Here's a wonderful picture of a nice U-shaped trough that you see in Washington State. Another feature we see are our hanging valleys. So a hanging valley is a tributary valley whose floor is above the main valley. So in this bottom picture, you see this is your hanging valley. So that valley is above the main valley floor that's shown by the arrow. Usually hanging valleys, not always, but a lot of the time, they produce beautiful waterfalls that you will see. Nice hanging valley right in this picture, and here's our water cascading down in a waterfall. Some other erosional features we have, you might see a cirque, which is a bowl-shaped depression. You can see I've circled it on the bottom picture. It is formed from either frost wedging, glacial plucking, or glacial erosion. You could have an arête, which this line represents right here. An arête is a narrow, serrated ridge between two glacial valleys or cirques. It's caused by headward erosion. You might have a horn, which is a steeped wall peak in the shape of a pyramid. Whoops. Right here shows a good picture of a horn. And then down here you notice the feature that's called a tarn. A tarn is simply a cirque that contains water. This next slide shows some actual pictures of these features. Picture A shows a nice cirque. Picture B shows a cirque as well as an arête. And then picture C shows a nice feature of a horn. Okay, this ends part 2 of chapter 13.